Good evening, everyone. Welcome to one problem per day, what you call it as daily practice problems. This is the fourth problem in the series, and let us start with this. So, this problem is from the chapter on mechanics, or HL and SL, it's the same one. So, a block of mass 45 kg is placed on a horizontal table. There is no friction between the block and the table. Okay. So, these are two blocks kept here, 15 and 45, and an object of mass 15 kg is placed on the block. Okay. There is no friction between the block and the table. So what he says is that no friction with the block and the table. Between this and this, there is no friction. So let me write mu equal to 0 here. The force F acts on the block so that it accelerates. The force F acts here because it accelerates. Definitely it has to accelerate because there's no frictional force. So even if you apply a slightest force, it should accelerate. Okay. The acceleration of the object and the acceleration of the block are the same so that they do not move relative to each other. Means what? So both the 15 kg and 45 kg are something like glued together. They're actually not glued, but they're staying in such a way that they're moving together actually. Okay, so why does it move together? If you ask this question, definitely I can say maybe this will have projections. The 15 kg object will have projections like this, and the 45 kg object will have projections like this. And these two are being fit into a lock and key fit model. They start moving like this. Okay. The coefficient of static friction between the block and the object is 0.60. So between these two, the friction is higher. So therefore, they just do not move away. State the nature and direction of the force that accelerates the 15 kg object. Now, this object gets accelerated because you are applying a force here. But why should this get accelerated? The reason is because of the static friction between these two. So it is something like this. Two objects are being close together, are being fit together like lock and key. And when this object, the lowermost object, is being pulled like this, the lowermost object moves and the uppermost object also, because of friction, it's being glued together like this and it also starts moving like this, right? So that's what is happening. So therefore, because of static friction and say the nature and the direction of the force, what is the nature of it? The static friction makes the 15 kg object to move in the direction of applied force. So this much you need to write. Okay, if you just say static friction, that's not sufficient. You need to mention static friction and what makes the 15 kg object to move in which direction. Okay, and you have to mention all of them. Okay, usually we always consider that static friction is something which which is against the direction of motion. But here you observe that it is aiding the motion of the upper object. Okay, so it's always against the direction of the relative motion between the two objects. Remember the definition between the two. Right. Next, let's move on to the next one. Determine the largest magnitude of force F for which the block and the object do not move relative to each other. Now the question here is that when you are applying the force, okay, you apply a force of 1 Newton, the force between them is so intact, the object will not slide. Okay, this object is moving, and this also will also together as a single system they start moving over here. But what is the max force that I need to apply? What is the largest magnitude of force applied so that this and this will always go attached together? Okay, and that's what has been asked over here. Now, how do we find it? Now, towards it. Now, what is the force? As I said here, see, the static friction force is the force that makes it to move like this over here. Okay, the force acting over here. What we do is let us find out what is the static friction here. The static friction here on the 15 kg object, okay, due to the 45 kg object, because between these two there is a friction here, right? There is a friction over here. The static frictional force, the frictional force between these two is seen to be frictional force acting on 15 kg is equal to mu times n. What is n here? N is nothing but m into g. Which m should I take? So this acts like a surface. It's only this 15 kg I should take as m here. I should not take 45 or 60. There's a misconception which many of the students do it. So see to it that, okay, so only if I consider this as a surface, I'm asking what friction is acting on this object. The friction that acts on this object is mu times. Mu is the coefficient of friction between the two surfaces multiplied by n. What is n here? N is nothing but m times g. What is m? M is the mass of this object. Therefore, I can now write 15 times 10 over here. And what is mu? Mu is 0.6. So this frictional force acting on 15 kg is equal to 0.6 multiplied by 15 into 10 is 150. So how much will be 16 into 50? 6 into 50 is 90 Newton. So this is the force that acts over here. Okay, now is this the answer? That is not the answer. Okay, so therefore 60 Newton is the force that is acting on this one. Now with what acceleration is this moving? So we can say the 15 kg object moves with an acceleration of, what's the acceleration? You can say that this is equal to the force divided by mass, right? So 19 by 15 is equal to 6 meter per second square. This is the acceleration at which the object is moving. Hey, here's the value of g given to us. Let's find out, because we assume g equal to 10. If it is given, it's okay. Otherwise, we can assume g equal to 10. Okay. So nothing is given, so you can assume g equal to 10 over here. Thus, we got the acceleration of the 15 kg object is 6 meter per second square. Okay, I hope this you have understood until now. Okay, now let me write down the diagram once again for the sake of clarity. So therefore, I have an object like this. This is 15 kg. We have another object over here. What was the object mass? Sorry, this was 45 kg. This was 45 kg. This was 15 kg. And this object was said to be moving with an acceleration of 6 meter per second square. What is this object moving with then? Though a force F is applied over here. If this object is moving at 6, what about this one here? This is also moving at 6 only. How do you know it is 6? We are not computing anything. We know this because both of them are being attached. They are not moving separately, right? If this is moving at 5 meter per second, the second one is also moving at 5 meter per second, right? If this is moving at an acceleration 6 over here, top one is moving at 6, bottom one should also move at 6. If they are moving differently, then what will happen? You can say that these objects are not tied together. It is like, for example, you are moving in a car. You see an adjacent car. Okay. Now, when you are seeing that if both the cars are moving with the same acceleration, then you see that both of you are at rest, right? Otherwise, what you will see? One of them will be speeding faster, other one will be slowing backward. That's what you can see, right? So there is no race over here. Both of them are moving with the same acceleration. So therefore, you can say this object is also moving at 6 meter per second square. But don't ask me what is the force here. The forces acting on this would be different. Okay, but the acceleration is one and the same. So therefore, both of the objects are moving at 6 meter per second square, which means I can now write this whole 15 and 45 as one block, right? One block, and all of them, both of them are moving at 6 meter per second square. Now, what else do I need? I need to find out what is the total force that is acting. Determine the largest magnitude of F, for which the object and the block and the object do not move relative to each other. Okay, which means that what is the maximum force that I apply so that both of them are moving with the same force. So we already calculated the maximum acceleration. If you go beyond 6 meter per second square, the object will definitely slide. The 15 kg object will stay back, okay, while the bottom object will start moving forward, right? So therefore, now we have the force F can be written as M into A. What is the M here? 45 plus 15, which is 60. 60 multiplied by 6, which should be equal to 360. What's the unit? Newton. 360 Newton. The maximum force that I can apply over here is seen to be 360 Newtons. Okay, I hope this is clear. So this question was a bit short. One question is what we thought. So anyway, so come to an end to this particular. Thank you.